So why ICVBM? The main question I frequently get asked is why should you, as a Cryptic Masons Medical Research Foundation, why should you send your funds and your support to something like the Indiana Center for Vascular Biology and Medicine? No one here has ever died from a biology disease. Vascular diseases, yes. But what many of us do not know is that vascular biology is truly the science that understands almost all diseases. It starts at the foundation to understand how the diseases progress. So what is vascular biology? Most illnesses, death, health care cost, vascular diseases, they're all related to some sort of vascular interruption. It could be from your blood vessels, even on a cellular level where we're no longer able to get the nutrition to the tissue that we need to have nutrition at. So one of the things that we like to talk about is, first of all, let you know what are cells. We're going to be talking about some technical information. Well, the human body is made up of cells. So if we're looking at how to make something better and how to fix something, you can't start at the problem, you have to start at the root of the problem. So we look at things on a cellular level. This particular graphic is that of the human skin. And you'll see that it's very similar to, how many people here are Masons? Not just in, very good. So we are Masons as an organization, but then we actually have skilled laborers who have done a little bit of brickwork. Cells are really amazing. They're made out of very similar building blocks, and they do very different things depending on how they're programmed. Some cells can carry oxygen to our body. Some defend our immune systems by invading bacteria. And some transmit signals to the body, almost a type of a Morse code. Sometimes they're electrical signals. But our cells have a way of communicating, not only to each other, but to the brain and other parts of the body to let them know when there is a problem. If you look around your house and houses around you, you're going to find that almost everything is made of building materials. Everything is made of some smaller component, whether it be a house, a bike, the table. Everything is made from a building block, if you think of things on a cellular level. And with all building blocks, when a structure becomes weak and you start to make your repairs, you should always start at the foundation. And sometimes a little new mortar, even a new block, like our stem cells, are needed. Many times a house will have a problem with plumbing, the roof leaks, and we call in a specialist. And this will be analogous to, I'm having a heart problem, so I'm going to go to a cardiovascular specialist. We find out that, yes, our roof is sagging and our plumbing has broke, but it all comes down to, what's the foundation of your house like? Is it sturdy enough to keep the structure in place? This is very similar to what we deal with in vascular biology. We want to know what's going on at a cellular level. Healthy blood vessels are really the highway to get these building materials to our job site. Stem cells travel very much the same way, and communication is the key. How many people here know what a stem cell is? Have I educated you enough in the past that we know the difference between, there's two types of stem cells. Can you tell me what they are? Very good. So most of our research that we're dealing with deals very specifically with adult stem cells, because we're finding that these are cells that we're able to get from a variety of different tissue, from our own body. We're looking at not only blood, but fat, bone marrow, and as I get into some of our new advances, we're going to have some new sources for our cells as well. And I want to draw your attention to this bottom right-hand corner. When I talk about communication as a key, sometimes merely the problem in our body is that one cell or a system has a block in communication. There are signals that are not getting out to the rest of the body to let it know what it needs, whether in the way of nutrition or stem cells that might be regenerating in our body. And this happens very commonly when someone decides to have a parade in the middle of Memorial Day weekend blocking up the interstate. So it's very important that as we do our basic science, we take these things into consideration. We're looking at communications at a very microscopic and macroscopic level to get all these organisms to speak together. And then when this very intricate, complex traffic pattern for the blood is blocked or otherwise compromised, every organ is potentially affected. So think of this Indianapolis, or around 465 or even 70 when there's a major wreck, it escalates. When one problem happens, something else usually happens. And this is very analogous with what goes on in our body. If we are obese, if we eat fatty foods, it can cause complications. It can cause atherosclerosis. Well, atherosclerosis, that's the hardening of the arteries, that's gunk in our pipes. It's not letting as much blood go through. So we can have a variety of different diseases from that. Everything from strokes, ischemia. Remember our peripheral artery disease, where people have difficulty in getting circulation to their appendages, their toes, legs, and arms. This is very similar. And damage to blood vessels, well, they can cause nerve damage, kidney disease, heart disease, and yes, even a loss of vision. So atherosclerosis, I spoke just a little bit about this. You know that this affects our heart, our health, our brain. It's a very big concern. Diabetes. I'm not going to speak much on diabetes because Carmela will be speaking on that today. But did you know that it can affect your brain, eye, heart, kidneys? Diabetes can affect almost every part of your body. And with the Cryptic Masons Medical Research Foundation, you have a global impact. This is very important for you to know. When you're making your donations and you're recruiting contributors to help us with our cause, it's not to help a center located just in Indianapolis. We are an internationally based organization. Dr. March is traveling today. We are constantly conferring with people to get other ideas. We're recruiting people in. We have people on faculty that have come from all over the United States. We have some people here right now who are here for 2-year and 1-year fellowships to learn with us. They will go back to their facility, their country, and hopefully take back some of the practices that they've learned both in basic science as well as medicine. And as you see here, ICVBM, we're in the center of many, many diseases. So we're interested in finding cures, not just for heart disease, not just for the atherosclerosis, but from things like cancer to stroke, diabetes, kidney failure, and wounding. Now, at our center, our key emphasis is trying to get our science and discoveries into patients as quick as possible. Basic science research can take years, 10, 12, 15 years. To fully research why and how something works on a very microscopic level. One of the things that we like to do is if we have a potential therapy, we will find a way to quickly get that into a preclinical model and hopefully get into a clinical model. Now, when I use the word preclinical, this means non-human. So clinic refers to an actual human case unless we're talking about vet medicine. And we have recently started expanding our areas of interest to help pets and companion animals. And you may ask, why would we be interested in that? Well, instead of having to use a laboratory animal that instead of having to use a laboratory animal to sometimes create our disease, we have found that some of these diseases like diabetes are occurring naturally with our pets. And so we are looking at combining forces with our veterinarians to get our trials and our potential cures into the pet population, and that's actually going to help us get it into the people population quicker. So with basic science, this refers to work in a petri dish, work in a cell culture hood, under a microscope. Preclinical, that's our little rodent here. And what we like to do is on our preclinical in our lab, we're one of the areas that we would like to specialize because we work with pig models and large animal models. The FDA really likes to see a lot of our our ideas and our thoughts used in a large animal model that's more analogous with human anatomy. And most of you may not know that the pig is very similar to humans. Cardiovascular system, dietary system, and we have one of the only natural occurring diabetic pig models in the world at our facility. This is run by Dr. Skirk. And Carmela, have you had an opportunity to use the Ossabaw pigs in research? They have a metabolic syndrome, and any of you that would like to know more about this, I can tell you about this offline. It's a fascinating story. We're very privileged to have these animals, and it's allowing us to find new advances in diabetic research that was not available with any other animal model. And in the past, you've heard me talk about our PAD treatment, surgical bypass, angioplasty, and this tied in quite closely with Dr. Murphy's studies that he was doing with trying to restore peripheral circulation to the limb. And this can be because of our atherosclerosis or a variety of other arterial diseases, including diabetes. But today we're going to do something a little different. We're going to be talking about a summary of present and ongoing research at our center. So I'd like to draw your attention to our handout, if you would. And if at your opportunity you would read the opening letter from Dr. March, this will tell you a little bit about what's going on at our center and explain more about who we are. And since most of you here have been here before, I'm not going to take that time to go through that today. But I do want to talk about our current projects. And everyone at every talk I go to wants to know, how is Dr. Murphy's trial going? So this is one of the very early projects that the CMMRF helped us get up and going, and we started to save limbs on patients that otherwise were scheduled for amputation. And something that I've brought with you today is actually a short 7-minute movie. Now, we are presently, on the third paragraph, you'll see that we are going to be conducting our phase 3 trial in 10 centers. Now, what this means is that Dr. Murphy now has to train other physicians around the country on how to do this technique, how to harvest the cells, how to process them, and how to get them back into the patient. So this is our final step to where we're no longer just recruiting those people who are high risk. This is very soon to be in the population of people who you don't have to wait until you're almost ready to be amputated. We are now finding that this is a very good viable treatment option for many circulatory problems. It's going to take me just a second, but I want to pull this movie up. And unfortunately, this movie cannot be filmed. So is it possible to turn our camera off?